Hello there. This video may look a little weird or lower quality than normal for my channel, but there's a very good reason for that. Now, if you've watched a few of my past videos, you may have seen that I have kind of a ridiculous amount of video, let's call it routing hardware, because I have a wild capture setup in my office here that lets me record video sources from across a room, but it's actually even more complicated than you might think from that. And today I want to talk about how I finally tamed all of my video problems by writing my own controller software that can remotely configure all of my video hardware over the network. Now, everything you are about to see is going to be recorded in one take, at least until I take off this hat, which I'm not going to do until I sit down at my workstation to show you exactly how this software works and how you can use it yourself if you want. Now, let me take a step back and explain a couple of things. What exactly is this and why did I need it? Well, this is essentially just a small Python script, but it has some really powerful configuration options that let anyone control almost any kind of device over the network or serial to be able to automate video routing. And that sounds like an easier thing to implement than it really is. Let me give you here's how you know it's not being edited. Let me give you an example. This is a Blackmagic ATEM Mini Pro ISO. This is the device that I use to control my main cameras when I'm recording, which are Blackmagic Pocket Cinema Camera 4Ks. I can have 4 HDMI inputs in this, and I can switch between any of those with these 4 buttons, and then the output is what gets that displayed. Now, you'll also notice that there is a small video frame right there. That is happening with this keyer, which I can enable or disable on this hardware. Now, this also has the ability to record, which will use USB-C drives. I have a SATA SSD sled here, and then it will record individual feeds for each of the HDMI inputs, as well as the 2 audio inputs and the output feed. Now, the other thing that it can do that is the real reason that I use this and why it's so powerful is that it will send the record signal back out through the HDMI connectors to the cameras, and then they will start recording on their internal SSDs, which gets me the best control over the highest quality recording sources I have, because I can mostly simultaneously start recording on all of them at once. Now, the problem is let's say I'm way over here and I want to switch to the ACAM and disable this miniature view that I'm in. Well, it's not actually that easy to do that. For one, there are no phone apps for this, at least not for Android, and the only remote control application for that hardware that Blackmagic makes is for Windows. Well, this is a Microsoft Surface, but I don't run Windows on it. There is an open source Linux switcher program, and it does work well, but it's meant to more mimic the Windows software, which is really just meant for initially configuring it or having like a control room that can operate everything. It's not set up for you to be able to create workflows, which is what I did. With my software over here, all I have to do is tap Facecam and bam, it has hidden the small view and shown this view. Now, I have extended this functionality not just to the ATEM, but also to Extron devices, the RetroTink 4K, and OBS itself. So let's take a look at a different example that doesn't use too much of the ATEM, but does use OBS and some of my Extron devices. And to do that, I'm going to walk on over to my vintage computer desk. Again, I'm not editing anything at all here. So this is where I set up my VGA vintage computers, and this is done for a reason. I have a KVM over here that lets me switch between the computers on this side, and then over here I have a dedicated setup. These are using VGA Cat5 extenders that amplify the video signal and send them over a long cable to a different part of my office. I'll explain exactly what all hardware is involved with that in a moment, but just for right now, note that I'm over here and everything for controlling the video signals is over there. So that means that once I'm starting recording, it can be difficult for me to get everything configured correctly. And we actually saw this in the Linspire PC video most recently, where I started out with the video capture on it, but then I ran into some issues that I didn't see because I was way over here doing the recording and I could not fix it. Now, I don't have a way of seeing the video output on here yet. I have an idea where I might be able to take screenshots in OBS and then display them on here, but this is going to make it much easier for me to configure the video correctly from here. So, first off, let me try and demonstrate this by just pushing one button. There we go, and after a little bit of back-end nonsense, we should see, bingo, the Linspire computer showing up in video capture. Now, I have done nothing other than tap Windows 98 PC here, because that's kind of what I think of the KVM that I have over here as mainly being for. Now, this is using Extron hardware to do this. This is not a particularly fancy setup, although I do have some fancy options, but I would be better off demonstrating that with the other computer that I have here, and that is the Windows XP PC, which is currently running Doom. Now, this is WinDoom 95 and it's running the Doom 2 WAD. Let me just clear my throat really quick here. That's a lot better. Okay. Again, I'm not editing this until we get to the point where I'm actually showing you the software. Now, this is running Doom on here, which the Extron over there has automatically stretched to fill the video frame, which is not ideal if you know how Doom works, which is one of the things that I have in this software that I can configure. So I can hit a 720 by 400 game mode, and it will rescale the video to be the correct pixel perfect resolution for video capture. But if you hate that, I also have an option where I can set the video frame to 640 by 480. Now, this is beneficial because if I dial in presets for the video cards or other hardware, I can rely on that being able to be enabled remotely with the software now, which is not something that I could do before. I would have to change the video source, go over to the computer, reconfigure the video output, come back, look at how it looks, and it's a kind of giant nightmare. This is going to massively simplify this, and it just keeps on getting better. Let's say I'm done with Doom, and I want to go back to the desktop. This is going to switch from 640 by 480 for the DOS Doom there, and it's now going to be 1280 by 1024, which I can press a button to have the video rescaled for here, which it may have already. I'm not 100% sure. I can't easily see the recording screen from here. So that is one of the most powerful things with how this is working. I have controls for switching between computers as well as the ability to configure the video for them. Now, let me show you one more really powerful thing. And to do that, we're finally going to go over to the Workstation. Now, this is the computer that I use when I want to actually work here in the office. This is the Threadripper that I was very kindly sent and put together in a stream, and it is water cooled. It is the first and only time that I've ever done any water cooling. But I'm running the software on here. I don't exactly need to. So the computer that I started out showing you over here, that is right there, is actually the stream computer, which is down below right here. And that is a touchscreen monitor, which makes utilizing this kind of stuff much easier. So I'm really looking forward to that. Now, if I go back to the capture here, I can start to demonstrate to you how this software really works and what exactly it can do. Now, I'm not going to guarantee this is going to be one take from here. So this is where the editing begins. All right. Let me start out by demonstrating one of the features of this and how this actually works. So this is the software running over here, and what happens is when you click one of the buttons on the user front end, it sends a signal to it over here, and then it executes a bunch of commands over to the hardware. Now, I have documented all of my video hardware in this setup in this spreadsheet, and I really needed to do this because it's such a complicated setup. So let's work our way back from the ATEM through to the video VGA computers over there. So we start out, we have actually the stream PC. This is what the ATEM goes into. So I have a Blackmagic Intensity Pro 4K in this, which it sounds like it would be a 4K capture card, and I have 4K cameras. None of it works in 4K. Blackmagic are kind of dirty liars about that. The cameras can record internally 4K, but they only output 1080p over HDMI, which is really annoying. And the Blackmagic Intensity Pro 4K capture card can only capture 4K 30 444, so it's really annoying. Anyway, the ATEM also only outputs 1080p, so this kind of works out. Now, one thing I haven't implemented in this is that I have a DataPath Vision HD4 in here, which is a quad input VGA capture card. I'll go over this more when I finally get around to the VGA capture video, which is becoming more of the video capture video in general. But I have two of the inputs from an Extron MPX866 in here, which we'll get to at the end of this. I also have a FireWire audio interface in this computer that I have a deck talk hooked up to so that people who cheer bits on my stream can have a fun TTS hardware. So the ATEM runs into the computer, and the computer is recording this. Now the computer also gets, and I can enable this here, a video feed from my phone. Now I have my phone set up way over in the vintage computer corner, and it is using DroidCam OBS to be able to send that video feed, but I can also just HDMI capture it. But for right now, it's easier to just use that. So with that, I can set this up over OBS to be able to control some stuff like that. So that one's like a pure network feature, so I don't really have it documented in here because this is more about the physical connections, which let's get to the ATEM. So the ATEM has two cameras connected to it, the one that you see when I'm working at my workbench to have me talk at you, and then the other one that is the ARM camera, and that one's actually on a Rode PSA-1. People get curious about that. It is not a perfect solution. I would love for there to be a piece of hardware designed for what I do with that, but such a thing just does not exist. So anyway, those are those two things. The output from the ATEM goes to the stream PC, as we saw. The other thing that connects to the ATEM, though, is input 3, which comes from an Extron IN1606. Now, I have all of my Extrons connected over my network, and I can go to the IN1606 here. So this is the normal network web page that you can configure the hardware through, and all of my Extrons in the office support this. I recently bought an Extron DTP Crosspoint 84, thinking that I could use it for HDMI routing at home, but it turns out they dropped the web interface like this, and they force you to use their software, which was one of the things that was the impetus for me to write my own software for this because they were jerks. I also have an Extron Crosspoint RGB 300 that doesn't have a working front panel because the flash is dead and it's stuck at executive mode, and I bought a RetroTink 4K, which just doesn't have any front panel buttons at all. So I kind of really needed the software no matter what. But anyway, I have the computer that you're currently seeing this on connected to input 5 here, but then input 6, if we go back to my spreadsheet, we can actually look at, that's the software, we'll get to that in a moment. If we go over to the IN1606, input 6 is connected to an Extron DVS510. Now I might eliminate the DVS510. It's not doing as much for me as I really need it to, but it does have a couple of features, so I don't know. Don't consider this a recommendation for the DVS510. The IN1606 can do almost everything that the DVS510 can do, and sometimes better. But the DVS510 is connected to the MPX866, and this is why this would be very easy to just bypass. But for right now, that's how it is. And I will mention that there was a weird problem with the DVS510 that I had to solve right before this, but we have to get into the software if you don't understand that. So anyway, MPX866. This is a VGA crosspoint matrix switcher. So what this is, you have a series of inputs and a series of outputs. I got those backwards. Anyway, you can send any input to any output. You get this whole grid that you can configure. So you can click anywhere in here and this will tie input 6 to output 5. That's how this works. So that's why you have this grid set up. Now, where this is really helpful is if you have, say, multiple inputs, like, say, VGA network extenders, and you have a single capture path, or maybe you want to be able to directly capture this stuff in a higher precision. This has the ability to also route this out to the data path card. Having a cross-point matrix like this is really handy. So this is the front end that all of the analog stuff goes into. Although I will say that the network extenders aren't the best for quality. The 1280 by 1024 from the Windows XP computer probably didn't look amazing. I've found that it has ghosting at higher bandwidths, so that's a little bit of a problem. Okay. So that's generally how this hardware works. If we want to capture from the Windows XP computer, it goes through the Extron MPX 866, and then I route that, boom, boom, over here to the DVS 510. The DVS 510 routes this. I guess this isn't marked correctly here. I can't remember if it's like output 6 or something. This is the IN 1606. Actually, it only has one output, that's right. So the IN 1606 gets the output from the DVS 510. The IN 1606 takes either the Extron DVS 510 or the Workstation, outputs that to the ATEM. The ATEM takes that, mixes it with everything else, and then sends that to the Stream PC. And then the Stream PC takes that, maybe the other audio sources, as well as my phone through the network side channel, and then creates my singular output, which is what I'm currently recording to make this video. So it's a very complicated setup, and there are a lot of options that I can configure along the way, which is why this software is so darn handy. It's super easy for me to switch between these video sources now, as opposed to going through all of the input nonsense that I have here, which is what I have been dealing with. So that is why I wrote the software. So let's finally get into what this software is and how it works. So, all right. This is really not easy to explain because the software may not do as much as you think it does because video hardware can be far too different. Everything you see here is actually generated from a single JSON file that is used to define your connections to your hardware, as well as the different interfaces that you want to have show up over here and what those buttons do. Now, I am not using all of the features that this software has here because I don't need them all for this, but this can do more than you can see here. And if you want to have an idea of what all it can do, you can go to GitHub, and I will link this down below because you can look at a lot of documentation that I've written for this so that you can understand how to use it, because it is so ridiculously complicated. Let me walk you through how this actually works, because it is not trivial to set up. And again, there's not a lot I can do about that. So first, this software has a concept of video controllers and sources. That is how I am differentiating the devices that you work with and the actions that you want to send. So here I have video controllers for the IN 1606, the MPX 866, the DVS 510, the DVS 510 again, the ATEM, the streaming computer, and then this one I chucked in there, but I'm not actually using it, my stream server, because I have the most ridiculous setup ever. Don't worry about that. Now, the DVS 510, let me quickly talk about this, because I discovered a weird bug with the DVS 510 right before I started recording this today, and I had to use a workaround for this. Now, the DVS 510 can work over Telnet or use an HTTP API. Now, if we go to the DVS 510 manual, I can search for CMD equals here, and we can see that this is how you send this hardware commands over HTTP, but it also supports Telnet. Up until now, I've been using this only with HTTP, but I found out today, as I was trying to do some more complicated stuff, that when you send it commands that need escape sequences, you can't actually put that in a URL. So I had to switch to using Telnet for it. But then when you connect to it over Telnet and you try to send it the same input that it is already on, it locks up for some weird reason. So using the HTTP interface to switch inputs and then the Telnet interface for everything else seems to be reliable. Now, you might think that that would be kind of a nightmare to implement, but that probably took me 2 minutes to fix, which is one of the areas where this software is really powerful, but to be able to know how to do that is where this becomes kind of a nightmare. So if you notice over on this side, we have lots of indentations and cascading areas, and that's because of how this works. So these are the video controllers, and then down here are the sources. Each source starts out as a dictionary entry in the JSON file. And you can see here we have location and then filming location. Up at the top, I have 3 filming locations set. When I click one of these, like let's say Workbench, it reconfigures all of the video inputs, for that location. You'll notice it has removed the little preview window up there, and we only have that camera. Now, if I go back to Workstation, it switched to the capture input on the ATEM, and then it's brought up this view here, which is actually a USB webcam that's connected to the streaming computer down here. Then the desk starts out by showing just my phone with a wide view there, and then I can click one of the computers in particular to drill down into, because I figure if I'm walking over there, I might want it to start off with that. And then we can hide some of that ugly video switching, but not all of it. Now, let's go back to Workstation. Anyway, so we have these 3 big buttons up here, and you can see that they kind of do a lot of things. For Workbench, we can define the name that shows up for the button over here. And here's one of the cool things that I have done with this software. I can change the name here. So Workbench Demo Live Change. All right, all I'm gonna do is save the file and then refresh the page, and this is now changed. Every time you refresh the page, it reloads your configuration file, which is super handy when you're configuring things live, but can also bite you if you mess up the Java formatting, because JSON. JSON is really strict about making errors and weird things. It's kind of annoying. If you're not a programmer, I don't know if this is really going to be the software for you, but if you are a programmer, you might see the brilliance in this. I don't know. So that's one of the things that we can do. We can also do something like change the background color here. So you'll notice that the VGA area is slightly blue. What I can do is I can change the background color to, let's just go with red. All right. And then I'm going to add a comma there. What did I mess up? Is that a semicolon? Yeah, it was. Okay, so we'll make that red, and then we're gonna make the text color just white. These are HTML commands, by the way, so we do that, we refresh, and bam, there we go. So we can directly set the foreground and background colors in this, which is pretty handy. So that just gives you an idea of how this works with the configuration options here. Now, every video controller up here has a key defined in this, and you can use that key as another key down here to say, I want to run these commands on this controller. You assign these to the different sources in here, and that is how the actions are tied to that. Every single source can have a key for every single video controller. Now these ones up top are really complicated, so let's go down to the ones for the VGA resolution options, because these are much simpler by comparison. So the first resolution option we have down here is auto image. And for that, we just connect to the DVS 510 and we send it to the command 2*A. Now, I can't wrap every single command for every single video controller because they are too weird and too complicated, and the software would just become a database essentially of generic command descriptions and hardware specific command entries. And The only thing you need to do to know what these commands are is just go look at the manual. So I would recommend that you look at the manuals for any hardware you have, because you're going to need to know what these commands are. Now, I've tried to help somewhat with this, and I'm working on explanations of how to use some devices. So for the Extron, for example here, I have written I think my internet just died. So for example, the Extron controller here, you can go through and you can see how you can initialize a controller. It tells you how the interface works for this. And then I've given a number of command examples down here, which includes the auto image commands. Although these can be different for different machines. So this one is correct, but I think some of them might require a backslash after the A. Or is that for loading a preset? I don't remember. Anyway. You'll need to know the commands because I can't have them all pre-programmed. So anyway, this is an Extron specific command, but you can just put it in here. Now, commands are stored as a list so that you can have multiple commands in here, which is how these commands work. These are the commands that set up the horizontal position, the vertical position, the horizontal size, and the vertical size of the image in the frame. So now it's changing the Doom video from 720 by 400 to 640 by 480. It was utilizing these commands here. Now, these commands are just a list of the different commands that you can send this, and these are executed one at a time. Now, up at the top, we actually have the option to define a command delay. So if your hardware needs a moment to process these commands, you can have this command delay, and it will wait that amount of seconds between sending the next command. So in this case, the DVS510 for normal commands here, I have waiting 50 milliseconds between commands. For the input switch, I'm having it wait 1 whole second. That way, I know that it's had time to get itself sorted out. So for each one of these resolution commands down here, we are sending the DVS510 4 different settings so that we can configure how it works. Okay, that one's easy enough. Let's go look at a slightly more advanced one for the ATEM inputs here. So under main source, I have the ability to just directly select the different ATEM inputs. And the reason I did this is because I don't want to have like Workbench arm or Workbench face. I want to be able to directly switch between these, but I do want them to make some considerations. So when I'm at the Workbench, let's go ahead and select that right now. When I switch to the arm camera, I want it to show this little view up here. You know, this one that my arms are wiggling in. So it needs to do multiple things at once. But the ATEM is really complicated. So the ATEM, I have, let me bring up my, no, this is a controller. Oh, this is slow. Oh no. Now the ATEM is very difficult to work with, and that's because I would classify the types of controllers I support here into 2 types: generic interfaces and dedicated interfaces. Now, the generic interfaces are the ones that use serial, telnet, or HTTP. The dedicated ones have specific Python modules that I import in order to work with. Now, in this case, we are using PyATEM Max to control the ATEM. And this has a bunch of functions or class members that you call to be able to do all of the different actions you want on the ATEM. You can't put function calls in a JSON file. So what I have done is a very complicated thing where you can define a dictionary entry, put the function name as a key, and then a list for the parameters. And now we'll finally look at the Python code, which is long-ish, not super complicated, but the way that this works, if we go to the ATEM part here, we check if the switcher class from the PyATEM software has the function that has been passed in the JSON, and then if it does, we pull that function out of the object and call it with the parameters that were passed. So this lets you directly call Python functions from the JSON data, which took a bit of work to figure out exactly how I wanted, mostly when it comes to OBS, because OBS is on a whole other level of pain. Now, if you do happen to have an ATEM, you'll notice that I have a lot of just weird magic numbers in here, and that's because this library, which works fairly well. It doesn't work perfectly. I haven't got any of the audio options to work in this, but the video stuff all seems to be working well. Anyway, this software has a bunch of like hard-coded enums in here, and if you don't know what that means and don't have an ATEM, just let it go in one ear and out the other. But you're gonna have to look up what the data objects are in this and then see what they are hard-coded to. I would recommend importing the class in a Python interpreter and then figuring out what the data like directly is, because you cannot put the object names for the enums in here. There is no way I could figure out how to do that without it being insane. So we directly call the Python functions by using this structure for the commands. And that's how we do just the face cam. So we set the input source to input 1, and then we disable the little tiny view where, you know, I am with the webcam here, right there. Where this gets a lot more complicated is OBS. So OBS has a WebSocket API that allows you to send commands to OBS over the network. You have to enable the WebSocket interface and then get the password and everything to log in. But it works fairly well, although it has been kind of crashing every now and then on me whenever I change something, but let's just chalk that up to the computer that I'm using not being amazing for it. Now, where OBS starts to break down is how it works with different kinds of data types. So if you want to change a scene in OBS, it's trivial. You set current program scene to the name of the scene, and that's fine. But let's say you want to hide a source. Like, let's say you have a phone that is remotely broadcasting data and you want to be able to show that or not. Well, welcome to my nightmare, because you can't just tell it the name of the item in the scene. Oh no, you have to get a scene ID. So the way that this works is in OBS specifically, I don't know if the ATEM needs this. I don't think it does. So I haven't implemented that. But OBS has the ability to chain nested functions using this whole ridiculous thing. But long story short, to get the ID for the item that you want to enable or disable, like my phone camera, first you pass a function that gets the ID, then it returns that as a value that you can use as a parameter, and then you can call the actual item enable or disable function. So this layout here is actually the same as this, but let's say this 0 here, we needed to query from the ATEM. We can replace this with another function call, and the return value of that function call is just passed on as if that was what was typed there. So here we want to change the scene item phone, but we have to get the item ID from the scene that it's in, and then we can pass that on. It's ridiculous. OBS's software is really difficult to work with, but I would say that's only because OBS itself is very complicated. You can do some ridiculous stuff with OBS, so I don't really know how else they could have worked with this, but that's what it is. So the other thing I will mention here is that this scene item ID is an optional thing you could do. We could eliminate this part here, and this will still work just fine, because the output from this function call, which is using the OBS Python WebSocket wrapper module here, when you call the get scene item ID function, it actually passes an object that has the scene item ID attribute, which then contains the ID. It doesn't just pass a number directly back. So if you use a dictionary and then put the key of the parameter that you want to pull out of the returned object in there, and then put the value of that dictionary as your function call, you can then specify exactly what parameter you want to pull out of the returned object. Again, it's ridiculously complicated, but there was no other way that I could do this without hard coding everything. That would be impossible to dynamically set anything up. So OBS is absolutely ridiculous for how you implement it, but it is possible to do some complicated things. So what else do we have here so that I can show you what nightmares are lurking? Well, you can chain commands. So here we are enabling or disabling the webcam overlay, which is what you're currently viewing me through. If we go to the desk scene, because it needs to be able to show the phone camera instead. And we also disable the phone overlay. So there's actually 2 phone cameras that are enabled. If I go over to OBS and I manually enable the source item and enable that, and there we go. That is the kind of cursed thing that I'm trying to avoid having show up, because we can see both phone cameras at once, which is not desirable. So I'm going to go ahead and apply the workstation config, which resets all of the settings back to exactly what I want. Those kinds of complicated setups are where this software shines, because we can enable or disable everything all in one go. And that's why we need to be able to have so many nested commands. Now, I think I've hopefully shown you enough so that you can understand how this works, at least partially, and why you need some of this stuff. Because let's say we want to switch to the Windows 98 PC here. If we go down to the Windows 98 PC sources, we have to select on the cross-point matrix the input to the output we want. We set the DVS 510 to the input that it uses for the matrix. We set the DVS 510 then again, after we connect over Telnet, to auto image so that it correctly phases and gains and all that stuff. Because if you turn on the computer and maybe I use the KVM to switch to a different computer, the image will be distorted if it's not correctly auto aligned. So we need to call that. Then we set the IN 1606 to have the correct input there. We set the stream PC up with the phone overlay in the upper corner. And then we disable the big phone overlay that was probably enabled when we got there. Now, one thing I could do at this point also is disable the webcam, but ideally what I do is I go desk and then this, but I could end up going just to this, which might mess things up. But I do want to limit some of what I put in here, but there's not a lot of choices for it every time. Okay, so we set up the PC, and then finally we switch the ATEM to the third input, which is where the IN 1606 is connected. We set the keyer source to the face camera input, the one that you can see when I'm working at the workbench. Actually, we could disable this. We could get rid of that, because the next line we do is we disable that entirely. I probably set this so that if I go back to the workbench, it doesn't have to reload that. It is one of those things where you can make a change in the background to like preload for something else. So anyway, we have to do so many different things here that it is kind of ridiculous. But with all of that, it's still not perfect, because there is one thing that we can't do, and it has to do with how you can see the ugliness of the video switching happening. So if I go workbench, and then I go desk, and then I go Windows XP PC, you will probably see it do some final switching to the Windows XP PC where the video, yep, there we go. It flashed one thing on the ATEM. We have random black. And actually it's going to stay black because the PC is like putting itself to sleep. But that doesn't, you saw it do some weird switching. Now, the IN 1606 has an option to fade to black, and we can also do a video mute or not. It would be really cool to be able to fade to black, and you can do this on the ATEM as well. Fade to black, do the switch in the background while the video is not being sent out, and then fade back to the video and display it after you do all your switching stuff. The one thing I have not implemented in this is the ability to call the same video controller twice in one action, which is kind of a hack job that I did here, which you could do to work around this. So let's say I wanted the ATEM to fade out. I don't know what the fade button is here, and I don't really want to look it up right now because it's always a pain in the butt to add an ATEM command. But let's say I wanted to add an ATEM fade up top first. What I would have to do is I'd have to go up here. I would have to copy this. I would call this, say, ATEM 1, ATEM 2. They can point to the exact same device. This just gives you 2 keys to reference this device by. And then we could go through and I could have ATEM 2 down here that fades in the video. And then up top, I could have ATEM 1 that fades out the video. Kind of an annoying, dumb setup, but it beats the alternative where the command set inputs get way more complicated, because I would have to put each of these into a list then that each have an order assigned to them, and then it would just be so much worse. Trust me, you wouldn't want that. So that dumb workaround is the better solution. All right. I think that might be everything. If you want, you can look through the code itself. I've tried to document it as best as I can, way more than usual actually, because the whole thing with the video stuff is that it is such a pain in the butt to keep maintained and utilized. So that's why I needed to write this software to simplify this. So I know that this is also some incredibly complicated software. Like one example here. Okay, this is one of those things where I'm just trying to plan ahead. So let's say you, the viewer watching this, only have an Extron device and you want to use this software to control that. Okay, what you can do is import the software or download it, clone it from GitHub, and then set it up for, say, Telnet. When you go to run it the first time, you have your Extron IN 1606 Telnet config, let's say. The first time you run it, it will try and import the Python Telnet module. It won't find it if you don't have it installed, and then it will tell you that it needs to install it. But it will not try to import the ATEM module because you don't have an ATEM configured. So this way, you don't have to have every single module installed that this supports unless you're actually using it. So that's one of the things where I've tried to think ahead for this. Let's see. Oh, I guess I haven't covered how the layout actually works. This is something that is covered in the documentation here, but you can nest sources in the layout. So let's look back at the config here. So first, we have the primary sources entry here. This is the top level, okay? We have the filming location, which is rendered here. Then I have a second sources entry here. Now, when you put a source list in a source item, it will render it as an HTML field set like this, and then put any name that you may have here up here as a legend. Now, the reason that the legend is important is, let's say you want to be able to hide this. Well, now you can just click the legend and that goes away. I actually have this set up so that when I first reload the page, the VGA capture area is hidden. That way I can't accidentally hit any of that, which is a nice thing to be able to block out if I want. So I can click this, bring this all back. Maybe I have set the PC that I want to set and I don't want to be able to change it. I can just leave it like that, or maybe I'm happy with the resolution and I want to be able to hide that. It's one of those features that just kind of naturally came out of this. But if you nest the sources like this, it will match the layout over here, and you can nest these indefinitely. So here is a group inside of a group, so that I can have the main sources split between sources on the PC, like my phone, and the ATEM. So source grouping is like that. Now, we can see here that the VGA sources are bigger. If we go down to that area here, we can see the name is set there, but then I have a description set here. Now on the home page for this, I show what descriptions look like when you implement them. But the thing is if you add a description, even if it's blank, it will change the rendering mode for that source item from a small button to a list item that fills the width of the page. This is useful for organizing the buttons, how you want them to be displayed. And I feel like that's a good way to go if you have like a couple of really big things that you want to be able to make like obvious. The other reason I do this is so that if you are adding icons to this, which you can do, you can make the icon items be wide or, have different options for how they're laid out. Because if you have different sized icons, you can end up with some like weird stuff with how things are laid out, but that helps make everything the same. So you can see down here for the VGA resolutions options, actually, the widths are all completely different, and you could, make them all identical by just having them go full width. But the downside of that is there's kind of a lot of options here that I'm going to be implementing, and I don't want to have like this be like a giant long page I have to scroll through, especially when I'm able to use this from my phone because it's a web page. On that, I didn't mention that. Launching the software, now I can kill this right here and this isn't a problem. When you go to launch the software, you can run the built-in help and it tells you everything that you need for setting this up. This does have a really cool feature. So if we do -S, you can see for the serial devices that are here, we have name as Greaseweasel, and then we have by ID and path, which is this whole ridiculous nonsense. If you have a serial device, like say the RetroTank 4K, or for me, I have to use my Extron Crosspoint RGB 300 over serial, and you have maybe the same serial device multiple times plugged in, like you ordered a bunch of the exact same one or something, you can use these values here instead of the dev TTY USB 0 or whatever as your way of connecting to these. I use a setup here where every serial port that's called checks against a Python serial object list, and then we'll get the dev TTY USB whatever thing by matching to this. So this makes it much easier to easily define serial devices like this, particularly USB serial devices, because when you go and plug these stupid things in, there's a chance that the USB paths will be different, and you can have them swap around in numbers and stuff and IDs. So they're kind of a pain in the butt to use when you have multiple of them connected. So being able to pick out something, especially something that has a specific name set like this, is really nice. But anyway, you can also set the interface that you're listening on. I guess I forgot to update the text for the port, but you can change the port. By default, it loads to port 5000. And then you have to pass the configuration file. Oh, this is one thing. You can set commands for the hardware that are called on the initial load. So I think I have the sources here. Yes. So, or no, controllers, that's what I want. Video controllers. Okay. So you can have a command init option set. So for your controller up here, we could add cmd underscore init. And let's say we always wanted the IN1606 to be on input 5 when it's first started. We could add that right here. And then every single time the IN1606 is first started or connected to by the software, it will connect that way. I have a bad Extron device. I may have mentioned this already, but the flash is bad and it's stuck in executive mode, my Crosspoint 300. So what I actually do is I have an init command on my configuration at home where it resets it to factory defaults on startup every single time. And then that allows me to reconfigure the device over serial. So that is one useful thing, but there is an option if you don't want to reinitialize the hardware with the command inits. So, I think that might be everything for this. So we can go ahead and go back to the workbench. Well, that is my software for controlling different kinds of video routing devices and how it can be used and implemented. It's not easy, I know, but it's the best that I could do given the variety of different kinds of interfaces and commands and just all of the things that are involved here. I tried to look up if something like this already existed, and I couldn't find something as flexible as this. There might be a few programs out there that can individually control these kinds of devices, but I couldn't find anything that really tries to bring them all together, which was the goal here. Sequenced commands for multiple devices to impact a big output, and I'm really happy with how this turned out. Well, if it sounds useful to you, it will be linked down below and you can find it. I guess I should mention here that this is a computer run program kind of meant for video capture. You can kind of think of this video as a prelude to the video capture series, really. It's never going to have an iOS or Android app version. That's just not something that will happen. Trust me, you don't want to try and write that JSON file because you have to manually write it on a phone. That would be terrible. So you're going to want a computer no matter what, and it's going to need to be run on there. It's written in Python. It uses Flask as the web server, but yeah, I think those are all the big points. If you found this video helpful, you may want to subscribe to be notified when I release another one. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time. This was the first video I ever recorded with OBS. It feels kind of weird because now I'm just going to tap stop recording over here to end it.